guys. Are you there? Hmm. Hello, guys. Good morning, guys. Good morning. So this is a tutorial. I'm gonna go over. I'm gonna go over the tutorial sheet number 8. Okay, so just bear with me. Share. All right. I'll give you some time. So this is can you all see this, guys? This is tutorial sheet number 8. Can you take a few minutes and see if you can do question 1? This is question 1. Is on all these questions are on confidence interval, which we covered before the Easter break. You may recall, right? So can you please try question 1 of sheet 9? Sheet 9, question 1. I'll give you like a few minutes, and if you can do it afterwards, I will show you how to do it myself. Okay, so can you take about 5 minutes or so and see if you can do question 1? Thank you, guys. All right. Any questions you guys have? Just you can use your microphone or you can use your chat box. I'll be able to see both. I'll be able to see your chat box. So if you have any questions, just write on the chat box or use the microphone. Okay, guys. Sorry. What did I do? Hello? What? Hello? Just a minute. There's something happened. So I'm doing. Come on. I'm doing sheet number 9, question 1. So if you look at sheet number 9, all right, this is question 1 on sheet 9. Could you take a few minutes and see if you can do question 1, please? Then after that, I will show you how to do that. Okay. Thank you, guys. So it's the questions. I'm sure you can read the question. It says you have a random sample of 81 students taking an achievement test, and their scores recorded. The sample mean is 74.6, and the sample standard deviation is 11.3. And the question is to find a 90% confidence interval for the mean. Okay, guys. So find a 90% confidence interval for the mean. All right. So can you do that on a piece of paper, please? Well, just a reminder that we are working on question 1. All right. I'll give you about 3 more minutes. After that, I will show you how to do it. Okay, guys. All right, let me show you how to do question 1. So if you're just joining us, we are doing question 1 from sheet 9. All right. So the question is asking you to construct a 90% confidence interval mean, and you're given a sample of You're given a sample of size 81 with a mean of 74.6 and a sample standard deviation of 11.3. Okay, so if you look at share screen. Share screen. Well, here we are. Okay, if you look at the stuff that we did in the class, you know, so I'm doing. So let's look at question 1. Okay. So if you look at the stuff that we did in the class, the formula for the confidence interval is the following: x bar is the sample mean, plus or minus. Because the sample mean is, so the population variance is unknown, you need to use the t confidence interval, all right, involving the percentile of the t distribution, which is this, and s divided by root of n. So this is the formula for the confidence interval. Now x bar is given to you. X bar is given to you as equal to 74.6, right? And you're given s. S is the sample standard deviation, which is equal to 11.3, and n is given to you, which is 81, right? And okay, now you need to read the percentile of the t distribution, which is, before I do that, let me determine what alpha is. Remember, we are looking for a 90% confidence interval, which means that 100 times 1 minus alpha is equal to 0.9, and this implies that alpha must be 0.1. Okay, so the thing you're looking for is Tn minus 1 minus alpha by 2, right? So this guy is gonna be equal to T n minus 1 is 80, and 1 minus alpha by 2 is 0.95. All right, and if you read this, I'm sure I gave you a copy of the T table. I don't have well, you can see it online in the course website, but if you read it from there, you will see it is equal to 1.6664. Okay, this is the value for the t percentile. So hence, hence the 90% confidence interval is the following. So x bar is once again 74.6 plus or minus 1.66664 multiplied by S, which is 11.3, and square root of 81 is 9. Okay, so this is the answer to the question. So the answer to the question is this one. Okay, so this is question 1. So if you're just joining us, this is question 1 from sheet number 9, example sheet 9. Okay, all right. Any questions on this, guys? I mean, do you have anything you like to ask me? Hello, guys. Talk to me.
Yeah, sir. We can hear you.
Is this clear to all of you or not?
I think it's clear. Yeah.
Okay, good. All right, thank you. All right, now
Yeah.
can you guys do question 2, please? Question 2 on sheet 9. I can show it. So let me share that with you if you don't have it in front of you. Question 2. Let's see where it is. This is question 2. Share. Stop share. Share. Yeah. Okay, can you see it now? All right, this is question number 2 on sheet number 9. Can you take a few minutes and see if you can do it, please? Right. So Hello guys, if you're just joining us, we are doing question 2 from sheet 9. Okay. Okay, let me show you how to do question 2. Okay, so all right, so this is question number 2. Oh, let me use not this ink. So question 2. So let's so you're told you have a sample size of 30. Is it number 30 data points, right? And you're also told that the sum of all the 30 data is equal to 1,568.45. All right. Okay. So which implies that which implies that x bar. Remember, x bar is the sample mean, which is the sum divided by the number of data. So it's gonna be 1568.45 divided by 30, right? And that's gonna be approximately equal to 52.2817. Okay, so that's your x bar. Now you can also compute this is the sample mean, right? Now you can also compute the sample standard deviation using the information that is given. Now I told you in the class that the sample standard deviation is, there are two definitions for it. One is a biased version, the other one is unbiased version. Now for this question, I will use the I will use the unbiased version, which is okay. This is the unbiased version. Okay, so now this you can rewrite it as, I think I proved this in the class in one of the exercises I did a long time ago. You can write this as follows. Okay, so this is the a different expression for the sample variance. Okay, and now you should sub in the information that is given to you, right? This will be n minus 1 will be 30 minus 1, which is 29. And the sum of xi squared will be which is already given as 83,000, and this number here, right? And n times x bar squared is n is 30 multiplied by x bar squared, which you already found, is 52 times 2817 squared, right, in brackets. Okay, so now if you compute this, guys, if you compute this will be equal to 34.67. Okay, this is what, so this is your sample variance. So this is the sample variance, guys, and this is the sample mean. All right. Now, okay. Now we can do the question. So the first, there are two parts to this question number 2. The first part is part A. Part A is asking you for a 95% confidence interval, assuming that the population variance is known and equal to 30. So we're assuming that sigma squared, which is the population variance, is equal to 30. And we are supposing that 100 times 1 minus alpha is 95%, which implies that alpha is 0.05, all right? Okay, so you should use the formula that I gave you in the class, which is the following: this x bar plus or minus z times sigma by root of n. This is the formula I gave you in the class, you may recall, right? Now x bar is, we already know what it is, which is 52.2817 plus or minus. All right, z 1 minus alpha by 2 is going to be 0.975, right? And sigma is 30, and root of n is root of 30. Okay. Okay, so you should simplify this. This is going to be 52.2817 plus or minus. Now, if you read this from the table, you need to use the normal table to read this. So if you read the normal table, it will be 1.96 multiplied by root of 30. Okay, guys. Now, that's the answer to the first part. That is part A. So let me put this in the right box. So this is part A of question 2. Now, part B. For part B, we are assuming that. Oh, somebody has a question. Oh yeah. Sorry, I think you're right. Yeah. Sigma. Yeah. Yes, you are right. Sorry, sigma is root of 30. Yeah, so it should be square root of 30 here. So both of them will cancel. So this will be just this. This is the answer. Thank you for correcting me. I appreciate it. Okay. For part B, we are assuming that the variance is unknown. So we need to use the formula that x bar plus or minus t n minus 1 minus alpha by 2 s divided by root of n. So this is the formula for the confidence interval when the variance is unknown, right? So this will become equal to 52.2817 plus or minus t. N minus 1 is 29. 1 minus alpha by 2 is 0.975. 975 multiplied by S. We already know what S is 34.67, and root of n is root of 30. Okay. Okay, guys. Now you can read this value from the t table. I gave you a copy long time ago. So if you read that from the t table, you will get the following. You get equal to 52.2817 plus or minus 2.045. Okay, that's what you will get if you look up the table multiplied by 34.67 divided by the square root of 30. All right, so this is the answer to part B of question 2. All right, guys, any questions? Are you guys okay?
Yeah, very nice, sir.
Okay, thank you.
Yeah, thank you so much.
Can you do the next question, please? Question number 3 on sheet 9. So let me share that just a minute. So let me stop this now. So if you go to question 3. Sure. Okay, here we are. All right. So this is question number 3 from sheet number 9. Okay, can you take a few minutes since you can do it? All right, guys. How are you getting on? How are you getting on with question 3? Um, all right. Let me show you how to do it if you haven't done it. So this is question question 3. Okay. Question 3. All right. So in this question, we are interested in the proportion of people or proportion of households that have 3 or more TV. All right. So let P denote the proportion. All right, let P denote the proportion of households with 3 or more TV sets. All right, so we want to find a confidence interval for P. Right, and you're told that out of 500 households, you have 80 that were found to have 3 or more television. So that means that the proportion, the sample proportion, X bar, remember X bar denotes the sample, proportion, right? So the sample proportion is equal to 80 divided by 300, right? Because it's 80 out of, sorry, 500. Or is it 5? Yeah, 500, sorry. My eyesight is not good. So it's 80 divided by 500, which is equal to, if you simplify that, 80 divided by 500 is equal to 0.16, I think, 0.16. All right, and we want to find a 90% is it 9? Is it, yeah, 90% confidence interval for P. Now, if you look at the notes I gave you guys, the formula for the confidence interval for P is something like this. This is the formula for the confidence interval for P. If you look back in the notes, you will see this. All right. Now our alpha is your alpha, because you want 90%. That means your alpha is gonna be 0.05. Remember, the way to work out alpha is like this. You set this equal to 90%, all right, and then solve for alphas, which will be, so alpha will be 0.1, actually, 0.1, okay? Okay, so this guy here will become like this. It will x bar is 0.16 plus or minus z 1 minus alpha by 2, it will be 0.95. X bar is 0.1 0.16 multiplied by 1 minus 0.16 divided by n. N is 500. Okay, so this is your confidence interval, and now you can read this value from the normal table. So if you read that from the normal table, it will be 0.16 plus or excuse me, plus or minus. It will be I think it will be approximately 1.645. Okay, that's the value that you will get if you read it from the normal table. And then you have 0.16 multiplied by 0.84 divided by this. Okay, so this is the confidence interval, the 90% confidence interval for the proportion P. Okay, so let me put this in red. All right, are you guys okay with this or no? If you have any questions, just write on the chat room. Okay, and okay, and okay. The next question, let's skip the next one, which is number 4. Can we do the next one, the one after that, which is number 5? Can you do question 5, please, now? Question 5. All right, so if you're okay with this, unless you have questions on what I have done so far, can you do question 5, please, which is, let me show you, sorry. Question 5 is over here. Okay, here we are. So this is question 5. Can you have a go at question 5, please? Are you guys okay? Oh, sorry. If you're just joining us, we are doing question number 5 from sheet number 9. Okay, so it says a psychologist measures something that is normally distributed with sigma equal to 0.05. What are the number of measurements she must take so that 95% and 99% confidence interval for the mean as a width not exceeding 0.02. Okay, all right. Okay, let's see how we can do this. Okay, so now the first thing you must realize is the confidence interval that you want to use. So let me go back to the Zoom. So we are doing question 5 now. Sorry. We're doing question number 5. Okay. So the first thing you must realize is that for this question, because we are assuming that the variance, the sigma is known, the confidence interval that is the following. All right, this is the confidence interval, right? Now the question talks about the width of the confidence interval. Now, can you tell me, like, if this is the confidence interval, what is the width? The width must be, remember, the width is equal to the difference between the upper limit and the lower limit, which is 2 times z1 minus alpha by 2 times sigma by root of n. Okay, and we know that sigma is 0.05, so this is 2 times z1 minus alpha by 2 times 0.05 divided by square root of n. Okay, so this will be 0.1 multiplied, sorry, not, is it, yeah, it's 0.1 multiplied by z1 minus alpha by 2 times 1 over root of n. So this is the width. Now the question is, we want the width not exceed 0.02, right? So we want this width. We want this width to be less than or equal to 0.02. Okay, so which implies that this implies the following, that you should divide by 0.1 on both sides, right? You will get the following, that okay. And this implies that the n, sorry, square root of n, right, must be greater than or equal to, correct me if I'm wrong, it must be greater than or equal to 0.2, right? So in other words, this implies that n must be greater than or equal to the square of this, right? Okay, so this is the this the solution for n. But now we need to consider two cases where number one is where you have considering 95% confidence interval. So in other words, 100 times 1 minus alpha is 95. So this implies that alpha is 0.05. So alpha by 2 will be 0.0225. So in this case, n will be greater than or equal to z 0.975 divided by 0.2 powers 2, right? Now, of course, you can read this from the table, and if you do so, you will get, if you read this from the table, you will get the following, I think. Correct me if I'm wrong, but if you read it from the table, you will get 1.96, I think. Is it one? Yeah, approximately 1.96 divided by 0.2 to the power 2. Right, so that's part one. Now part two of the same question is you want the percentage to be equal to 0.99%. In other words, this is equal to 99, which implies that alpha is 0.01, which implies that alpha by 2 is 0.005, right? So in this case, your n will be greater than or equal to square, right? And this is, I think if you read this, it will be approximately 2.58 divided by 0.2 square. All right, guys, so this is question number 5. So what I've just done, if you're just joining us, we just finished question 5 on sheet number 9, okay? All right, so now it's approaching 11 o'clock. So, all right, can we take a break, guys, for 10 minutes? Then I will join you. I will leave the Zoom as it is, but let's take a break for 10 minutes. Then I will continue afterwards. Okay, is that okay with you guys? Just 10 minutes, okay? 10 minutes, and then we will continue with sheet number 9. So just for those of you just joining us, we have done question 1 to question 5 from sheet example sheet 9. Okay, so we will do the remaining questions in the next hour after taking a 10-minute break. Okay. All right, guys. Just maybe you can go and have tea or coffee or whatever. Yeah, in this time. I'll talk to you guys in about 10 minutes, okay? Hello, guys. All right, guys. So let's continue from where you are. So we've done the first 5 questions on sheet number 9. So the next question I would like you to do is the following. So can you have a go at question number 6, please? Question number 6 on sheet number 9. So here you have a male population, and the blood pressure is normally distributed with mean, mu, and variance sigma squared unknown. Suppose you have a random sample of 30 and with x bar equal to 127.442 and sample variance equal to 228.661. And the question is to find a confidence interval, 98% confidence interval for mu and for sigma squared. All right, guys. So can you go at this, please? Question 6. Question 6 on sheet 9. Hi guys, are you okay? So I just asked you to do question number 6 on sheet 9. Okay, take your time. Okay, I'll give you about another 3 minutes or 4 minutes. After that, I will show you how to do question 6. Hey guys, all right, let me show you how to do question 6 now, okay? If you haven't done it already, I mean, I'm sure some. So this is, all right, this is question number 6, sorry. All right, you are told that x bar, okay, this is what is given to you. X bar is equal to 127.442, and that's the sample mean. And you're also given the sample variance equal to 228.661. Okay, and you're also told that n is a sample size, is equal to 30. All right, now this is all the, and we want to find the 98% confidence interval. So which means that 100 times 1 minus alpha is equal to 98. So this implies that alpha must be 0.02. Oh, is that right? Yeah, 0.02. Yes. Okay. So this is all the info that is given to you. The next thing is to find the confidence interval for mu and the confidence interval for sigma squared, right? Now the confidence, okay, let's start with the first part, which is to find the CI for the population mean mu, right? Okay, so in this, so you're gonna use the formula that I gave you in the class, which is x bar plus or minus t. Remember, because the population variance is not known, you need to use the t confidence interval. Okay. So this becomes x bar becomes 127.442 plus or minus t n minus 1 is 29. 1 minus alpha by 2 is 0.99, and s is the square root of 228.661, and n is the square root of 30. Okay, so this is what we're getting. And now if you read the t table, right, I gave you a copy of it long time ago. So if you read the t table, this is what you will get. You will get this to be equal to, this is 29, right? 29, you'll get that to be equal to 2.462. Excuse me, 2.462 multiplied by the square root of 228.661 divided by the square root of 30. Okay. So this is the confidence interval that you will get for the population mean mu. All right, are you okay so far, guys, or no? If you have any questions, feel free to Zoom. Use the chat box, right? Okay, so this is the confidence interval for mu. Now the next one, part 2, is Oh, sorry. Part 2 is asking you for the confidence interval for sigma squared, right? Now, if you look at the notes I gave you guys, the confidence interval for sigma squared is the following. I mean, if you look back in the notes, you will see this. Right, this is the confidence interval for. Okay, before I write this, let me put a heading. Sorry, excuse me. Just I'm being stupid today. So let me put the heading that this is confidence interval for sigma squared, right? Okay, so if you look back in the notes I gave you, this is the formula I gave you, if you remember. This is the formula that I gave you for the confidence interval for the population variance, right? So using this formula, you will get the following. So n minus 1 is 29. S squared is already, we know what that is 228.661. Okay, divided by the percentile of the chi-square distribution. I gave you a table a long time ago, you may recall. It's chi-squared, n minus 1 is 29, alpha is 0.02, so this is 0.99, right? And then you have the same thing, 29 multiplied by 228.661 divided by chi-squared 29, 0.01. Okay. So this is 29 multiplied by 228.661. Now, if you read from the chi-square table I gave you guys, this is what you will see. This value here will be 49.59 approximately, and excuse me. And this guy here will be 14.226. Okay, so this is the final answer for question 6, right? So let me put this in red also. So this is the final answer. Okay. All right, guys, you have questions? Any questions so far? Let me know, please. Are you okay, guys, or no? Hello, are you okay? Yeah. All right, so that's the question number 6. The final question on sheet number 9 is question number 7. So there are 4 parts to that question, so it's a little bit involved. So can you have a look at it, please? Question number 7, which is the final question in the sheet, right? Unless you have some questions on what I have done so far. So can you look at questions? Okay, let me show you what. Let me show you the. Oh. So this is question number 7. This is question number 7. All right. Can you see how you can do it, please, guys? Question 7. I'll give you a few minutes and then I will show you how to do it. Are you guys okay? Are you guys doing question 9 now? All right, so let me start by doing the first part of question 9. Mm, all right, so this is question 7. Question 7, part 1. Okay. Can you read my writing, guys? Because the pen is running out of the ink. I need to refill the pen. So if you can't read my writing, please let me know. Can you read my writing? Okay, because it's running out of ink. All right. The first part is to show that about the variance. All right. Hello. You're told that. Hello. You're told that y is equal to ax plus b, right? So the expectation of y, which is mu y, is basically the expectation of y is equal to the expectation of ax plus b, right? Which is equal to a times the expectation of x plus b, right? Now the expectation of x is denoted by mu x plus b. All right, so that proves the first assertion, right? Now the second assertion is about variance. The variance, all right, sigma y squared denotes the variance of y, okay, which is, hello, you okay? Which is equal to the variance of ax plus b, okay? Now the variance of ax plus b, I'm sure all of you know, is a squared times the variance of x, okay? And variance of x is denoted by a squared times sigma x squared. So we have proved both relationships, that is mu y is equal to a times mu x plus b, and we have also proved that sigma y squared is equal to a squared times sigma x squared. So that's part 1. Now part 2 is about the sample. These things are population values. Part 2 is about finding sample values. Okay. So you have yi is equal to a times xi plus b, right? And y bar is the sample mean of the y's. So this is 1 over n times the sum of the yi's, right? Okay, so this will be 1 over n times the sum of axi plus b. And if you have any questions, just please use the chat box, okay? Right, now, because a and b are constants, you can do the following. You can write this as 1 over n times a times the sum of xi. Now the sum of b is simply n times b. Okay, so this becomes a times 1 over n times the sum of xi plus b. Okay, so this is a times x bar plus b. Okay. All right, so we have shown that the sample mean for the y's is a times the sample mean for the x's plus b. Okay, is that clear, guys, or no? Hello, guys. Are you okay? And we also need to show the same thing for the sample variance. So let's start with the sample variance for the y's. Now I'm going to use the unbiased version, which is 1 over, it doesn't matter which version you use, it's the same. So I will use the unbiased version, which is this. This is the unbiased version. Let me know if you can't read my writing, because my pen is running out of ink. All right, so if you can't read my writing, please let me know. Okay. Okay, guys. I hope to get a new pen soon. So this will be 1 over n minus 1 yi is, we know yi is axi plus b, and y bar we just showed in the previous thing that y bar is ax bar plus b. So when you take minus, it becomes minus ax bar minus b. All right, so the b and the b cancels, so you get 1 over n minus 1 a squared times xi minus x bar squared, right? You with me? All right, a squared, you can pull it outside, so this becomes a squared times 1 over n minus 1 times the sum of xi minus x bar squared, right? Now we know that this term here is exactly the sample variance for the x's, right? So we have shown, so what we have shown is that the sample variance for the y's is equal to a squared times the sample variance for the x. Do you follow me or no? Any questions, guys, so far? Please. Hello, guys. Any questions so far, guys? Can you use the chat room if you have a question, please? Use the chat room. So that's part 2. Part 3 of question 7 is about confidence interval. So it says that you have a confidence interval for mu x and a confidence interval for mu y, and we need to show that. So all right, so let's see how we can do part 3. So we've done the first 2 parts of question 7. This is part 3 of question 7. So what it says is that you have 100 times 1 minus alpha for confidence interval for mu x, which implies that the probability that the probability that mu x lies between Lx and ux is equal to 1 minus alpha. Remember, this is how, when I talked about confidence interval long time ago, I mean in the lecture in the halls of, in one of the halls of lectures, I talked about it. This is the definition of a confidence interval, right? Now this implies that you should multiply all the terms within the brackets by a This is what you get, right? You with me, okay? And then you should add the number b to all the terms in brackets. You get this. Okay. And now this, according to the question, you should look at part 3 of question. According to the question, what I have just written is the probability that L of y less than or equal to mu of y less than or equal to u of y is 1 minus alpha. All right. So hence we have shown. So hence right. So we are done. So we have. Do you follow my argument here, guys, or not? Hello. Please let me know if are you able to follow my arguments for part 3. Yeah. If you don't, please let me know. Hello. Yeah. Okay, good. Thank you. Good to know that. All right, and the final part of question 7 is the following. The final part of question 7, this is the last one. Part 4, right? You are told that there is a confidence interval for sigma x squared, which is from V to W, right? So basically it means that the probability that sigma x squared lies between V and W is equal to 1 minus alpha. Okay, so this is what is given to you, right? And we want to find the confidence interval for sigma y squared, right? So what I'm going to do is I'm going to multiply all the terms within the brackets by sigma squared. Okay. Sorry, not sigma squared, a squared. I mean a squared being. I mean a squared. I meant. All right, a squared times vx, a squared times sigma x squared, a squared times wx equal to 1 minus alpha. Okay, so So this becomes, excuse me, we know that a squared times vx is equal to vy according to the question, and we also know that a squared times sigma x squared is sigma y squared. That's according to the first part, and the last one, a squared times wx, we know is wy. Okay. All right. So that's what you get, right? And so we are done basically. So we have proved. So hence we have proved that the confidence interval from so hence we have proved that the confidence interval from so hence the confidence interval from vy to wy, right, is 100 times 1 minus alpha percent ci, right? Is a 100 times 1 minus alpha percent ci for sigma y squared. All right, I'm really finding it difficult to read my own writing because of the ink. So I hope you can read my writing better than me, better than I do. All right, so that completes question number 7, which is the final question on sheet 9. Okay, guys, do you have anything that you like to ask me now or later or whenever? Okay, thank you. Okay, guys, thank you, guys. So I will talk to you again tomorrow. Tomorrow we have classes from 11 o'clock to 2 p.m. So 11 a.m. to 2 p.m. We have one lecture from 11 to noon. Then from noon to 1 we have a tutorial, and then from 1 to 2 we have another tutorial. Okay, guys. So I will see you tomorrow. And but if you have questions before that, you know what to do. You can email me or Zoom me any time of the day. Okay. Okay, guys. Have a good day and enjoy the time. Okay. Bye, guys.